Hello friends, welcome again. I am going to show you a demo and then we are going to talk about what is it. So we start and you see how the LEDs are glowing in a pattern. So they are chasing each other. This is called LED chaser, and how we have designed the design looks so simple yet fascinating results are there. I have created this using only a single IC, which is 744017, or you can just remember the last 4, which is called 4017. 4017 is basically a decade counter. So what is a decade counter? A decade counter means it will count from 0 to 9, and it will have 10 outputs, that means 0 to 9. Only one output will be 1 at a time if you keep reset as 0, and if you reset it at any time it will come back to 0 counting. So there are 10 outputs, output number 0 to 9, and they will be on one by one in the sequence. After 9, again 0 will be on. So simple operation in a single IC. How do we use it? Very simple. So what I have done here, I have taken 9-volt power supply. I am going to tell you one more thing. This IC ideally, which is called Johnson Decade Counter 4017, works at 5 volt. Earlier I had told you that we don't have 5 volt battery. We have 6 volt or multiple of 1.5. We have 9 volt. Okay, so how do you generate 5 volt from that? There is an IC called 7805, which is called regulator or voltage regulator IC. You can also have it for other voltages, but they are not available in the library right now, but you have 7-8 series. So what we do, there are 3 pins. The first one is input. So your battery input, which should be more than 5, will come here. Ground will go to ground, and output. So if you see this battery input, I have not connected to these rails. I have connected this only to the IC, and output of IC, which is 5 volt, I am giving to the rails, both on the upper and lower side. So this is how you can get 5 volt from a non 5 volt battery. Now I have used one more thing for the first time here, which I introduced previously, that is called function generator. Using a function generator, you can generate 3 different types of waves: a square, sinusoidal, or triangular. You can generate frequencies from 1 Hz to 1 MHz. You can keep amplitude from 0 to 10 with an offset or without offset. So to generate a square pulse which will go from 0 to 5 volt, I should keep amplitude as 5 and offset of 2.5, so that, because if I don't give offset, it will be from minus 2.5 to plus 2.5, which I don't want. So I give a padding or offset of 2.5, so minus 2.5 plus 2.5 becomes 0, and the upper limit, which was 2.5 plus 2.5, becomes 5. So my voltage of the waveform is 0 to 5. I can select any frequency. I have kept around 10 Hz. Then I look at this counter. In this counter, if you look at the pin diagram, there are 10 outputs. There is a clock, there is a reset, there is VDD, means 5 volt, and there is a ground. So connect those. I have connected ground. Now I will color these properly. This is my VCC. I will make it red. This is reset. We said reset should be kept to 0 for normal operations. And here is my clock at this pin number 14. The clock is coming. There are 10 outputs. I am using 5 of them. So the first one, this is output 1, output 2, output 3, and two respective LEDs, and I have just jumbled it. You should make it in a clear way as I taught in the previous video. Every LED is connected with a resistance of around 100 to 200, and then as we expect that this will be on, then this, then this, then this, then this, then there are five more outputs which will be on. That means these five will be off for that time, and again this will be on. This is how it will work. So when I start the simulation, my frequency is 9.67 hertz. If I reduce this, if I increase, you can reduce the frequency manually here. I keep it, let us say, very low, 3 hertz. Okay, so now you see all are off. Slowly, then all are off, then slowly it goes. You can control the frequency and make it very easily. You can connect 10 LEDs and make a fascinating circuit called LED chaser. Now I want to give you one challenge. Can you connect more than 10? Can you connect 20 LEDs? Or I want to give you one more challenge. I want my LED pattern to be first going this way, then coming this way. Right? So start thinking, start developing these hobbies, and try to find out the ways in which you can do the modifications on already existing things. We'll meet again with a new circuit. Thank you.